we're going to start on lesson 8.5, and we're actually going to kind of break it into 3 days, all right, because there's a lot of meat in here. And one of the strategies you're going to learn from this lesson actually will carry over to the next several lessons, okay? So this is lesson 8-5, and today we're going to focus in on factoring out what I'm going to call a GCMF. GCMF. And we'll explain what that means in a minute. So today's date is the 14th of April. Okay, so factoring, let's just write that word out. We've talked about factoring before. It's the inverse of distributing. So it's still distributing. It's a different way of doing distributing. Okay? So factoring is the inverse of distributing. In other words, you're going to put parentheses, if I could spell today, parentheses, back into the problem. Now, the most common issue students have is when you're factoring something out in your minds means to the atmosphere, and it's just genie blink disappears. The problem is now you've changed the value of your item. So when you factor, you will always get a product. Now that product may have 1 factor, 2 factors, 3 factors, 4 factors. I mean, we've had problems with 5, 6 factors depending upon what the problem has. So will always be a product. So that means 2 or more things being multiplied together. Okay. So today we're going to, again, this is very, very simple on what we're going to get. So what we're going to do is kind of show you what we start with, and then we're going to show you what we're going to end with. So let's take a problem like 5x times 3x squared minus 7. So this is what we did in the first half of the chapter. And to simplify, the only thing we could do is to distribute and remove parentheses. So we multiplied 5x times 3x squared, and we got 15x cubed. And then we multiplied 5x times negative 7, and we got negative 35x. So what you're going to work on is starting with the 15x cubed minus 35x, and you need to figure out what those two things have in common. Okay? So what values do 15x cubed and 35x have in common? So you will need to look at two different parts of this. You need to look at the coefficient part. What do 15 and 35 have in common? 5, okay. And what do x cubed and x? So we look at the variable part. They have an x in common. Now, this doesn't go away. It goes out in front. And then I just do 2 little mini division problems. So I got 15 divided by 5 is 3. X cubed divided by x is x squared. So I'm going back to not even the first part of chapter 8. I'm going back to chapter 7 with our basic rules. And then we have a minus, and then 35 divided by 5 is 7, and x divided by x is 1. And what we end with is what in the first half of the chapter we started with. Okay? So we're just going in a reverse process of what we're looking for. Now, technically, the 5x is called what? It has a name. It is a monomial, but it's the greatest common factor, right? Now, I say that would be GCF, but I wrote GCMF. So let's figure out what I mean by that. Now, your book doesn't talk about this, but I do. This is going to be your greatest common, and what did you tell me 5x was? Monomial factor. So tonight, that's your focus, is to look at a problem and to ask yourself, what's the greatest common monomial factor? I'm going to look for two parts. Okay, I'm going to look coefficient-wise, I'm going to look variable-wise. Now, in this particular case, we only had one variable. In some of the cases, there'll be multiple variables, and you'll have to ask the question for each variable, okay? So let's just write down, here, let me highlight GCMF, and then we'll go there. Now, I am going to tell you, starting tomorrow, our greatest common factor may be a binomial. And so that's going to be the biggest part of what we're going to be doing is looking for common binomials. But I'm going to teach you ways to do that so it kind of just magically happens, all right? No, it's not magical, it's math. All right, so let's write down our process. And this is always, anytime you're asked to factor, and this is the one step that gets missed, you always, always, always look for GCMF, always. And then look what you have left. Can you do more, okay? So oops, sorry, that's not going to work. So number one thing is you look for a GCMF in the polynomial. So one, what is the common factor for the coefficients? Sometimes you won't have one, it'll just be one. That's the first question you ask. What is the common factor for the coefficients? If it's one, then you're not going to pull anything out. Two, what is the common factor for, and I'm going to write this and yell at you, each variable? Okay? Those together form your GCMF. So the answer to number one, and number two is your GCMF. So if distributing is multiplying and we're doing the reverse, the math that we're actually doing is, all right, I'll try that again. Okay, so if distributing is multiplying to get rid of the parentheses, and factoring is the reverse of that, we're going to be doing division. There we go. Okay, I know it's Thursday, and it's a short day, but so now what you're going to do is divide. So I'm going to box that. All terms by the GCMF. Okay. You're going to get some remainder. I'm going to just call him remainder. In fact, I'll go one step further. Remainder polynomial. Okay, remainder polynomial. Your answer will take the form of GCMF times remainder polynomial. Don't throw the GCMF away. Okay. So with our homework tonight, our remainder polynomial, there won't be anything we can do to it. But that's only tonight. Starting tomorrow, we may have a GCMF, but our remainder polynomial, there may still be more that needs to take place. Or we may not even have a GCMF, but there's something we can do to that remaining polynomial. Okay? So let's do a couple practice problems. Jack, is that a question or a stretch? Okay. Everybody good? Dun, dun, dun. So the directions are going to ask you, let's see how they use it. I mean, why did they say this? use the distributive property to factor each polynomial. You know how we usually see it written as? Factor. Okay, I love how our book is telling you exactly what to do. Okay, factor. So we have 27y squared plus 18y. All right, so let's start with the coefficients, 27 and 18. What do those two have in common?
9.
Okay, so we have a 9. Hold on, I'm just looking at the 18. Now, y squared, y. What's the greatest thing I can pull out of both of those?
1.
A y. Okay, so can we come up with a rule maybe? If we're trying to figure out how many variables that we can pull out for our GCMF, is there something that we can use to help us figure out how many we get to pull out? So how did we figure it was y? Why wasn't it y squared? Yeah, the second one only has one y. So could we come up with a rule of where we should be looking when we're doing our GCMF as to what variable, how much of a variable we can take out? Okay, all right, and what will the exponents, what kind of exponent are you going to look for? We're going to pull out the greatest one, then I should be pulling out a y squared. Then the least. So we're going to look at the smallest exponent is the greatest thing they have in common. Don't you love how math works that way? We can be least and greatest all at the same time.
But if you just subtract the y squared minus the y.
No, you can't. And the reason why you can't subtract is because those two are not the same. Okay? So you can't just say 27y squared plus, or subtracting whatever, 18y squared. But what we're going to be doing is using our rules. And our rules do say that you have, when you're dividing and the bases are the same, you will subtract the exponents. Okay? So what we're going to pull out is our 9y. That is our GCMF. Let's figure out what the remaining polynomial is. So what's 27 divided by 9? Y squared divided by y. And then it says plus. 18 divided by 9 is? And y divided by y is? So your answer is 9y times the quantity 3y plus 2. Now, what I notice happens sometimes is I'll see this problem and I'll get this answer. If you notice inside the parentheses, there's still something 9 and 6 share in common. So that is something to watch out for, is to make sure you're not pulling out a common factor, but the greatest common factor. So always be checking your remainder polynomial. Did I get everything? Because I guarantee you there's going to come a point where you're going to miss something. And threes, for some reason, I call them stinky threes because they like to hide out in positive or evens and odds, and people just think it should only be an odd number a 3 can go into. So people forget that piece, okay? So we're always looking at our remainder polynomial to make sure there's nothing more to pull out. All right, let's try another one. How about negative 4a squared b squared minus 8ab squared, and then plus 2ab. Okay? So what we're going to do is to look for something they all have in common. So again, it's a division problem, so I'm going to set this up as division. All right. So let's look just at coefficients. We've got a negative 4, a negative 8, a positive 2. What can I pull out? Okay, we can pull out a 2. All right, let's look at our a's. I have an a squared, an a, and an a. So what can I pull out? Just an a. I'm limited to the smallest amount of them. And then b's, I have a b squared, a b squared, and a b. So what can I pull out? B. So my GCMF is 2a b And let's see what the remainder polynomial is. So negative 4 divided by 2 is negative 2. A squared divided by A is A. B squared divided by B is B. Negative 8 divided by 2 is negative 4. A divided by A is 1. B squared divided by B is B. Plus 2 divided by 2 is 1. A divided by A is 1. B divided by B is 1. So what do I have left? That is the most missed piece. The most common answer I get for a problem like this is that. Here's the rule. However many terms you have in the beginning polynomial, you better have that many terms in your remainder. Okay? So if everything cancels out, you still have a replacement for it. It is still the number 1. Okay? Now, there's a secondary answer to this problem with a slightly different GCMF. How could I alter my GCMF for this problem? Yeah, I could pull out a negative. This is also an acceptable answer. If I pulled out negative 2AB, how's that going to change the remaining polynomial?
All the signs are going to flip.
All the signs are going to change. So a negative 2AB becomes a positive 2AB. A negative 4B becomes a positive 4B. A positive 1 becomes a negative 1. Both answers are perfectly acceptable. Kind of the rule of thumb is if the first term is negative, you pull out a negative. But you don't have to. That's just, again, mathematicians want to look at a positive term in their polynomial, and so they tend to pull out a negative. But you don't have to. Both the answers are acceptable. Okay? So again, how can we determine that we've done the math right? We just go the reverse process and we distribute. We make sure that 2 times negative 2 is negative 4, that A times A is A squared, that B times B is B squared, that 2 times negative 4 is negative 8, that A times nothing is A, B times B is B squared, that 2 times 1 is 2, and A times 1 is A, and B times 1 is B. And that's it. Okay? All right. I'm going to give you guys 2 to work on. Easy, right? Oh, and by the way, when I give you time to work today, you're going to have to stay in your own seats because you guys get a little loud. All right, go ahead and work on that one. And I've got a second one for you. All right, in the number 3, how many terms remained in your polynomial in the parentheses? 2. Okay, good. How many terms remained in your remainder polynomial in number 4? 3. Okay, just make sure we understand. We had 3 terms, we still have 3 terms. We had 2 terms, we still have 2 terms. Who thinks they had the right answer for number 3? Johnny Ray. Okay, and we can say 3 times the quantity. That means the same thing as parentheses. So 3 times the quantity, 5W minus V. Anybody with a different answer? Okay, good. Natalie, you want to do the next one?
Yeah. UT times the quantity 7UT plus 21T minus 1.
And that's exactly right. Okay, you guys did a good job. Now, what was interesting on the first one, there were no variables in common. What was interesting in the second one, as much as it looked like it was going to happen in the beginning, there was no coefficient they had in common. At first I thought, oh yeah, we can pull out a 7, but then that UT at the end had no coefficient other than 1, so that left us at we couldn't pull out a number. Okay? And that's all. That's what you do. Okay?